Welcome to my kcse revision channel, Marita James, Girls Boys High School. Kindly subscribe, click the notification bell, you get notified once I upload a new video. In my last video, I summarized a whole summary of nitrogen and these oxides. And today we are looking at the preparation of ammonia. So our topic today is ammonia. And in ammonia we have two preparations. We have the industrial preparation and then we have the laboratory preparation. So we have the ammonia. In first we can start with the industrial preparation. In the industrial preparation, so we need to have first of all the raw materials required for the industrial preparation. So in industrial preparation, we have the raw materials and their sources, and of course we can have the conditions. So one of the raw material required for the preparation of ammonia is hydrogen. Hydrogen, you can get it from a cracking of alkanes. You can also get it from crude oil, or you can get it from biogas. So one raw material is hydrogen, which is obtained from cracking of alkanes. Another material is nitrogen, which you can obtain from the fractional distillation of liquefied air. So in this step, as in my earlier discussion, I talked about the isolation of this nitrogen from air, whereby the gases are first purified to remove the dust particles and impurities, and then passed through either potassium hydroxide or sodium hydroxide to remove the carbon dioxide. Then from there, the air is cooled to negative 25 degrees to remove water vapor, and then finally now it is taken in a compression where the air is compressed to a pressure of 200 and a temperature of negative 200, and then we have in that process is a repeated expansion and a contraction, whereby now the gas will change their state from being a gaseous state to a liquid state. In that stage now, the fractional distillation is carried out, where now nitrogen is being one of the gases being obtained as a component of air. So we have nitrogen, which is obtained from the fractional distillation of liquefied air. Now, what are the conditions? What are the conditions for hydrogen and nitrogen to react? So we have the conditions required in this industrial process. So one of the conditions we have an iron catalyst. The catalyst must be finally divided to increase the surface area for the reaction. Another condition is we have a pressure of 200 to 500 atmosphere. But in an examination setting, a candidate or a student, you are not supposed to give a range of this pressure, but you give a specific value, which lies between 200 and 500. So somebody can write 250, 300, 450, but the values will not go beyond 500 and they cannot be below 200. So the range is not required when answering this kind of a question. Then we have a temperature, which is a temperature of 450. So these are the conditions for the industrial process. An iron catalyst, a pressure of 200 to 500 atmosphere, and then we have a temperature of 450. Now, what are the steps followed in this industrial process? The steps followed, one, we have purification. And why is purification important? Purification is important to remove the dust particles and impurities which might poison the catalyst. Therefore, we have purification where nitrogen and hydrogen are purified to remove dust through a process we call it electrostatic precipitation. And the purification is important, is important to avoid the poisoning of the catalyst. So why is purification important? It is to remove the dust particles which might poison the catalyst. So another step 2, is compression. The gases are compressed to increase the pressure. So why is compression important? It is to increase the pressure. High pressure vapors a high yield of ammonia. A reaction between nitrogen and hydrogen to form ammonia is an exothermic reaction. So in Form 4, in the topic of Form 4, factors affecting the rate of the reaction, you will discover that increase in pressure favors the side which has a fewer molecules. More of that factors affecting the rate of the reaction you will study in Form 4. Now another step we have is heat exchanger. In the heat exchanger, the main thing that you are supposed to know from the heat exchanger is the role of the heat exchanger. What is the purpose of the heat exchanger? The role of the heat exchanger, the heat exchanger, one, it is to heat the incoming gases. For instance, it is heating the incoming gases of nitrogen gas and hydrogen gas. So the purpose of the heat exchanger, or the role of the heat exchanger, it is to heat the incoming gases. Then once the gas comes in the heat exchanger, of course they can react and then they form a product which comes out. And therefore now, another role of the heat exchanger, it is to cool the ammonia gas produced. The two gases will come in the heat exchanger, they will be cooled, the ammonia gas will be produced, and then the heat exchanger can also cool the ammonia gas produced. The heat exchanger can also be used to maintain the reaction temperature, and also it can be used to recycle the heat. So you need to know the purpose of the heat exchanger: to heat the incoming gases, to cool the ammonia produced, to maintain the reaction temperature, and to recycle the heat. Then another step followed, we can have the catalytic chamber. In this catalytic chamber, this is now where the reaction takes place. This now will require these conditions here for the reaction to take place. So in this catalytic chamber, you should have a finely divided iron catalyst. As I've said earlier, that it must be divided to increase the surface area for nitrogen and nitrogen and hydrogen gas to react, so it is increasing the surface area. Then we have a temperature of 450 and 500. I've given you a question that in an exam you are not supposed to give the range. Just give a value ranging between 450 to 500. Then we have a pressure of 200 to 500 atmosphere. So this one here, these are the conditions in the catalytic chamber, which will enable the reaction of nitrogen and hydrogen to take place. Now that is now the steps followed in the industrial preparation. So we have industrial preparation, the raw material, steps followed, purification, the compression, heat exchanger, and then we have the catalytic chamber. Then step number 2, we have the laboratory preparation. From here we are talking about the industrial preparation, where you require the raw material and the conditions, and now here we have the laboratory preparation. In lab preparation, you must have the reagents. In my diagram here, we have this diagram where we have a round bottomed flask, which is slanting downwards from left to right, and then you have ammonia gas. The ammonia gas is collected by the upward delivery as shown on this diagram. And then we have a number of calcium oxide. The purpose of this calcium oxide is used to dry the gas. Then the reagent used for the preparation of this ammonia gas, laboratory preparation, is a mixture of a slaked lime, which is a calcium hydroxide, and ammonia. And then this mixture must be dry. So they must be dry. So the mixture of a calcium hydroxide and ammonium chloride, they must be dry. Otherwise, if they are used to being moist, the ammonia gas will be dissolved, and therefore there will be no gas which can be collected. So this reagent must be dry. Now, what are you supposed to know? A reagent, so you must have a dry calcium hydroxide and ammonium chloride. They must be dry. You must have to mark. This is the key point. The reagent must be dry. Then we can have, of course, the calcium hydroxide, which is dry, combining with ammonium chloride, which is also dry. Then you can collect the ammonia gas. Then, as you can see from this diagram here, the orientation, the orientation of the conical flask, the round bottom flask, it is slanting downwards. So the round bottom flask should be slanting downwards to prevent water from flowing back, which may crack the flask. So the reason why this thing slanting downwards, it is to prevent the water vapor that can condense, then it flows back, which might cause the cracking of the flask. So sometimes you will be given this diagram in an examination. So instead of this one pointing downwards, it will now, or the orientation will be upwards. Then you will be asked now in this case to identify the mistake. So you can say now, if it is a mistake and then if it is pointing upwards, then that one is wrong because water formed will flow back and then it might cause the cracking of the round bottom flask. Now, we have the calcium oxide. The purpose of calcium oxide is to dry the gas. So, once the gas has been dried by the use of the calcium oxide, should be collected by the upward delivery, or we call it the downward displacement of air. So the methods of the gas collection is collected by the upward delivery, and the reason why it is collected by the upward delivery is because the gas is less dense than air. So that is the reason you can give. Why is the gas collected by the upward delivery or downward displacement of air? Is because the gas is less dense than air. Then I have said earlier that the calcium oxide is used to dry the gas. We have some other drying agents, like for example, we have the concentrated sulfuric acid, and then we have anhydrous calcium chloride. So the two cannot be used to dry the ammonia gas because the ammonia gas will react with the concentrated sulfuric acid to form ammonium sulfate. It can react with the anhydrous calcium chloride to form a complex compound. So the two will not be used to dry the gas. So the most suitable drying agent for ammonia gas is calcium oxide. Now, what is now? How can you test for that the gas produces ammonia? So you can also be asked, describe an experiment to confirm that the gas produces ammonia, or state how the ammonia gas is produced. So how the ammonia gas is being confirmed. So test for ammonia gas. So first of all, you dip a glass rod into a concentrated hydrochloric acid, and then bring it into a mouth of a glass which is full of ammonia. Then now you dip that glass rod into a concentrated HCl. Then you bring it into a mouth which is full of a gas jar full of ammonia. When the hydrogen chloride gas combines with ammonia, it forms a white fumes. So simply that is how you can test for the gas. So you dip a glass rod into a concentrated HCl and bring it into a mouth of a glass jar full of ammonia. It forms a white fumes. Now, what are the physical properties of ammonia? The physical properties of ammonia: it is colorless, it has a pungent smell, and the gas is highly soluble in water. So when carrying out an experiment, all of you asked now that draw a well-labeled diagram when I want to show ammonia gas, when ammonia gas is dissolving in water. So you must make the use of the funnel. The use of a funnel, so you can make the use of a funnel when you are being asked to draw that diagram for the ammonia gas to dissolve in water. So you can use the use of a funnel. You can have that this is water, and then you can have this one as this is an inverted funnel. Why do we use the funnel? The funnel in this case it has two purposes. One, to increase the surface area for the ammonia gas to dissolve in water. So that is why we are using the inverted funnel. Another purpose of this funnel, it is to prevent the water from sucking back, which might cause the cracking of the round bottomed flask. And now, so the gas is highly soluble in water, and this now, if you will be required to have an experiment, you must make the use of the funnel. Now, what is now the chemical properties of water? The chemical properties of ammonia. Chemical properties of ammonia, it reacts with the HCl to form a white fumes. Get a KLP, top notch, or any other revision book, and then you will get more chemical properties of ammonia gas. Now, we can also have the uses of ammonia. So we have uses of ammonia gas. Uses of ammonia. Now, what are the uses of ammonia? So you will also be asked, give one use of ammonia gas or two uses of ammonia gas. So it is used for softening of hard water. It can also used for the manufacture of ammonium nitrate. Get KLP or other revision books, you will get some uses of the ammonia gas. Now, in this experiment, you can realize that the calcium hydroxide is commonly used. The calcium hydroxide is commonly used. Now, what are the reasons why the calcium hydroxide is commonly used in this experiment? One, it is readily available, so it is available, and then it is cheap, then it does not corrode the glass, and that is why we have the calcium hydroxide is commonly used in the laboratory preparation of ammonia. Kindly follow my channel, click the notification bell, you get notified once I upload a new video. In my next video, I will be uploading one-page summary for the preparation of nitric acid, laboratory preparation of nitric acid in Oswald process. This is a one-page summary that can assist you to revise well when you are revising for your kcse examination. Thank you.